Hello everyone, welcome to our presentation. Our team members are Yisening, Pengfei Chen, and Wenhao Xu, and today we will introduce our work on diffusion models and how we improve their sampling quality and speed. So first of all, what are diffusion models? They actually generate image by learning how to reverse a noise process, and here we focus on DDPM, which is the noise in diffusion probabilistics model, and accelerated using the DDM later. So the diffusion models are powerful, but will suffer from the computationally expensive status. And the standard PDPM is slow due to making 1,000 plus inference steps and operating on the pixel level. So some practical impact is that we will enable faster and more efficient high quality image generations for real world deployment. And the task is actually to implement and improve the latent diffusion model from scratch. And the datasets we use are ImageNet 100, which is 130K image across 100 classes. And the assumption is that the latent space will preserve some semantic structure that could be useful in the later phases. And first, we actually implement the DDPM, which is actually a UNet architecture. And together later, we actually apply the VAE to encode the latent space and also decode it after generation. And after that, we add the classifier free guidance CPG for the conditional generation. And some comparison between the scheduler of DDPM, DDIM is that DDIM achieve more than 20% speed up with little quality degradation. So this is actually really promising, and both schedulers will support flexible variation handling. And there are some configurations for our experiments, and you can see that there are optimizers and also the scheduler sampling step and the backbone that we use. And we actually use the VID, the Frenchet inception distance, and also the inception score for the evaluation matrix for both quantitative and also the perceptual quality that the image generated. So some exciting techniques that we use is actually first one, the input shapes are constant throughout the training. So this one could save us up to 30 to 40 higher throughput on the fixed shape CNN, such as the image classification or diffusion model units. And the second part is actually to compute the VAE encoder once and use the latency in data loader later. So with these two, the training time of one approach of DIT train is actually shrink from 40 minutes to the 17 minutes. And then we actually use the V prediction instead of the epsilon prediction because this could make the losing weighting become time independent and to avoid overemphasizing early time steps. And also the model with the V prediction could show less color drift and need lower guidance scales. And at higher resolutions, it often beat the epsilon prediction on VID and also the human preferences. And the fourth techniques is actually the EMA weight averaging. So using the smoother weights is actually causing us to have a lower FID or SS, and because that could dampen the noisy SGD updates and acts as a low pass filter, which consistently improves the image quality for those models. And so talk so much about the DIT. So the DIT is actually different from the UNets in the background because the UNets use multi-scale CNN blocks with skip connections, while the DIT replaces those blocks with a vision transformer that runs on the latent patches. And when to choose the UNet or VIT, if you need quick experiments, limited GPU or pixel level tasks, you will definitely go for UNet. And if you want higher resolution, multimodal context, DIT would be a better choice. And there are actually some researchers already blending two words, combining UNES and also DIT. And here are some of the research model that we will showcase here. And there are some results about the DDPM scheduler and DDIM scheduler. You can see that the generated image contains certain patterns that is generated in the denoising images. And the DDIM could offer a practical trade-off between the speed and quality with up to 20% speed up in the inference. And the conclusion is that DDPM actually generate high quality image, but suffer from slow inferences. And the DDIM could provide faster sampling and can tackle with slow inference part with very minimal quality loss. And the latent diffusion models could, together with the classifier free guidance, could offer promising next step. And after we applying so many optimization on the training, we can see that it can definitely boost speed and stability in the models. And here are our references. Thank you so much for listening.